morning. It's nice to be here again. Um, we are going to be looking at series of questions taken from the West African Secondary School Certificate Examination (Waec) and 2012 to be precise. Now, some questions were strategically selected from that year, and we are going to look at um, a few of them this morning. All right. The very first question we are going to be looking at, I would advise you to pay very good attention and make sure you focus while I explain this. Is on ionization energy. Ionization energy. So the first question is, what is meant by first ionization energy? All right. What is meant by first ionization energy? And this question is saying that we have more than just one kind of ionization energy. We have the first ionization energy, and we have the second, we have the third in some cases, as the case may be. All right. Now, when you hear ionization energy, simply put, ionization energy is the amount of energy that is required to form an ion. All right. Now, what exactly do I mean? When you see gaseous species, an example of gaseous species is your hydrogen gas, is your oxygen gas, and the likes. All right. You understand that gaseous species, of course, they are also atom, and we are talking about atom. Atom has in its core, it has the nucleus there, and surrounding the core they are the electrons. All right. So these electrons, they are always orbiting around the nucleus of the atom, and what will happen is that when you are talking about ionization energy, you are talking about the amount of energy that is required to get rid of an electron that is most loosely bound. Now, when we talk about most loosely bound, what exactly do I mean? Let's go to the board. Taking oxygen, for instance. Oxygen, all right, the atomic number of oxygen is what? Is 8, right? Oxygen is 8. Now, when we are going to be talking about how the electrons are arranged around it, let's represent it using this. We know that it has a core inside where we have the nucleus, of course. So electron will be here, electron will be here. All right. You know that the very first one that we are going to draw, only 2 electrons will be there. All right. You can draw the next core, and the electronic configuration of this is simply 2, 6, since it is 8. All right. The number of electrons that will be here is 1, 2, 3, 4, 5, 6. Okay. Now, when we are talking about ionization energy, we mean the amount of energy that is required to remove one of these most loosely bound electrons. You can realize that there's an electron here very close to the nucleus. Those ones, they are not loosely bound, they are closely bound, held firmly as a result of the electrostatic force between the nucleus and the electrons. So they are tight, like closely tied together. But the amount of energy that you need to remove one of these electrons in the extranuclear shell here, that is what, in the outermost shell rather, that is what is meant by ionization energy. All right. And when we are talking about ionization energy, the first ionization energy is the energy that you need to from the gaseous species in its neutral state, the energy you need to form an ion out of that gaseous species in its neutral state is what you call first ionization energy. All right. You would understand it better with this. Let us assume we have a gaseous species, M gaseous. Now, what will happen is a certain amount of energy has to be applied on this gaseous species. You realize that I did not put any charge here. It means it is neutral. All right. The amount of energy that you need to exert in order to get rid of an electron. And what kind of electron? Like I said earlier, most loosely bound electron from this atom in its neutral state to now form an ion is what you call first ionization energy. So in this case, it will now be, you can now have something like M, depending on the number of electrons that you remove, N plus and plus N electron, and therefore you can talk about first ionization energy. All right. So now what you have done is, because you removed an electron from this atom in its neutral state, forming an ion, so the energy with which you are able to remove that electron, to knock off an electron from the atom in its neutral state, is the first ionization energy. All right. It will be good for me to tell you that now the second ionization energy, that is the energy that you need to remove further electrons from this atom, now not in its neutral state, because you already formed an ion. All right, the amount of energy that you need to knock off an electron from this one now will now be the second ionization energy, and it will be by far greater than the first ionization energy, because as you proceed it becomes increasingly greater, like it becomes increasingly difficult to remove an electron from an atom. So that's all about the first one. I believe you understand that. All right, let's go straight to the second question. The second question is on your knowledge of chemical bonding. All right, it's list three properties of electrovalent compounds. List three properties of electrovalent compounds. All right, let me get rid of what we have on the board so that we can focus our attention on the second part of the first question. That's question 1b. Now, list three properties of electrovalent compounds. What are electrovalent compounds? Simply put, electrovalent compounds, they are ionic compounds. And all right, when you talk about electrovalent compounds, they are always formed, they are always as a result of the combination of a highly electropositive atom and a highly electronegative atom. All right, what exactly do I mean? Let us take sodium for instance. Sodium is having 11 to be its atomic number. All right, now the electronic configuration of sodium in this case is going to be 281. I believe you understand that. All right, when you are going to draw let's draw the electron dot representation of sodium. All right, when you have this, you have something like this, and you have something like this, 2, 3, 4, 5, 6, 7, 8. Now there's a shell more. This is 1 here. This is 11. All right, so I'm saying that ionic compound, they actually compound that are formed when a highly electropositive atom, I think I explained electropositive atom in my last class. All right, electropositive atom, they are atoms in group 1, group 2. Group 1, that's alkali metal and alkali earth metal, of which sodium is a good member. All right, now when you talk about electronegative atom now, all right, example of electronegative atom is your chlorine, and chlorine is actually 17. All right, when you are going to do that, it's going to be 287, and when we are going to do the same thing which you have done here, all right, 1 2 3 4 5 6 7. Okay, awesome. All right, this is chlorine, this is sodium. Now when these atoms come together, you realize that, well, okay, let me just explain that. When we talk about bonding generally, I think this understanding of this will aid you in getting this concept very well. All right, when we talk about bonding, the reason why atom bonds is that they want to be stable. Do you understand? They want to be stable, and the only time when they can be stable is when they have the octet configuration, that is having 8 electrons in their outermost shell, or when they have the duplet configuration. Now duplet configuration means having 2 electrons in their outermost shell. All right, you can realize that if this sodium is just able to get rid of this 1 electron, it's going to have how many electrons in the outermost shell? 8, because this shell will no longer be there. And look at this chlorine here. All right, it's having 7 electrons in the outermost shell. It needs how many electrons? It needs just 1 electron to have an electron in the outermost shell. So what will happen is that this sodium, because it is having in excess and it is ready to give out, so this electron is going to be what? Transferred. It's going to be transferred there. And what you have is that this electron that is in excess here will be brought here, and that kind of bonding, it is called ionic bonding. All right, let me write it on the board for you. Bonding formed as a result of transfer of electrons is called ionic bond or electrovalent bond. All right, so you can call it ionic bond because electron is being transferred from the electropositive atom to the electronegative atom, so that is ionic bond, and the compound form is called ionic compound. Now the question, back to the question, is list 3 properties of electrovalent compound or ionic compound. All right, one is that, okay, let me just clean this. I believe you get it. Number one thing is that they are always solid of high boiling points. they are always solid of high boiling point or liquids of high oh excuse me, they are always solid of high melting point. Of course, you know, solid will melt to become liquid, all right, and they are always liquid of high boiling point. That's number one thing. So number two is that we have to give three. Number two is that, all right, when they are in aqueous solution, they are always good conductor of electricity, and that makes them electrolyte. You know, electrolyte, they are compounds that when in aqueous solution or in molten state, they can conduct electricity. So when they are electrolyte, let me just write that they are electrolyte because they can conduct. All right, the third feature of electrovalent compound is that they form crystals. They form crystals. All right, that's one of their feature. And let me just add one and let's leave the question, although we are told to just give three. Another is that they are soluble. They are soluble in water and other polar solvents. And other polar solvents. So that's about the question. So these are we are told to give three, now I've given you four. So you can do it to learn more about this and you'll be fine with that. So 1, 2, 3, 4. These are the features of electrovalent compounds.